Good morning, third graders. It's good to see you back here for our DMA. We're on week 34, day 2, and it's Tuesday. So let's go ahead and start warming up with some problems for our day today. And these again are all review problems, so these should be fairly easy for you to do at this point in time in the school year. So let's go ahead and look at our first problem for week 34, day 2, and it says for us to round each number to the nearest 10. Now, we need to make sure that we know which digit is in our tens place. So this 70 is going to be our tens place, and this 50 is going to be our tens place in 354. Now, when we're rounding to the closest 10, that doesn't mean that we don't have a hundreds place anymore. It just means that all of those tens that are between 900 and 1000 are still there, but we're using them to round to the closest 10. So 979 is going to be between 970 and 980 because the 7 is in the tens place. Now, think about what's right down the middle of 970 and 980. Right, 5 is always going to be in the middle of our two tens. So, 975 is in the middle of 970 and 980. So now, if I take a look at 979, which 10 is 979 closest to? Is it closer to 970, which is in the tens place there, or 980? Right, since it's past the 5, or 975, we know that it's 1 away from 980. So this is going to round to 980. Now, I'm going to round 354. 354 is going to be between 350 and the next 10, which is 360. And remember, 5 is right down the middle. So if I think of 355 is going to be between 350 and 360. Now, 354 comes right before 355. And since it comes right before, that tells me that it's going to be less than 355, which means it's closer to 350. So we're going to round 354 to the nearest 10 of 350. Now, I can go ahead and subtract, and I'm going to start off by using my break apart strategy first, and then I'm going to show you using the algorithm. So 900 minus 300 is 600. We didn't have to borrow because, of course, this is our hundreds place that we're subtracting. I have 80 minus 50. And again, I can subtract 50 from 80. So that tells me I have a difference of 30. And so when I put the hundreds place and the tens place back together, I get a difference of 630. Now, I can also do this by rounding to using the algorithm. So 979 minus, we're rounding, rounded, 980 minus 354, or 50, is going to be, again, 600. Well, we have, okay, hang on there. This Emil needs a little bit more room. So I think I'm going to do it up here instead. So I'm going to take this 980 and subtract the 350. I'm going to start in the ones place because if I needed to regroup, I would have to make sure I could borrow from the next place value over. 0 minus 0 is 0. 80 minus 50. So I need 3 tens here because 8 tens minus 5 tens is 3 tens. And 9 hundredths minus 3 hundredths gives me 6 hundredths. So 630 is about what this is going to be closest to whenever I go ahead and subtract. So my estimate is 630. Now I'm going to go ahead and I'm going to use this room up here at the top to check and see how close my estimate is when I actually subtract 979 minus this 354. So again, I start in my ones place. 9 minus 4 is 5. And I do not need to borrow because I have enough ones to subtract 4 from the 9. I also do not need to borrow in my tens place because I have enough tens to subtract these 5 tens. So 50 from the 70 is going to give me 2 tens, which is 20. And 300 from the 900 is going to give me a difference of 600. So 625, is it close to 630? Yes, it sure is. So this estimate is a pretty close estimate to what we have here. Now, what I want you to do today for your discussion is instead of rounding to the nearest 10, what I want you to do is I want you to round to the closest 100. And I want you to see how close it is to this 625 when you round to the closest 100. So again, I'm going to repeat what our discussion question is today. Instead of rounding to the closest 10, what if they asked you to round each one of these numbers to the closest 100? And what would be the difference if you were to round to the closest 100? Okay? All right. I'll be looking and checking and seeing what we come up with. All right, let's go ahead and take a look at the rest of our problems. We have a division problem here. We have our total objects. We don't know how many groups we're going to break them up into, but we do know how many are going to be in each group. So we're looking for our groups of 2. So how many groups of 2 is it going to take for me to make 10? Well, if I put 2 here, that's a group of 2. And if I put another 2 here, that's another group of 2, and now I'm at 4. If I put a group of 2 here, now I'm at 6. If I put another group of 2 here, now I'm at 8. And finally, if I take 2 more and put it into another group, I have 10. So how many groups of 2 did I end up with when I took these 10 objects apart? Right, I have 5 groups of 2. Now, with this problem, I'm missing my total objects here. I don't know how many objects I have, but I do know how many groups I have, and I do know how many is going to be in each group. So if I have 7 groups of 2, I can use my multiplication to help me find what my total was before I divided it into these groups of 2. So 7 groups of 2 is going to be, yep, you guessed it, 14. So my missing dividend here is 14. This is called your dividend divisor quotient. Dividend divisor quotient. Now, let's go ahead and take a look at my last multiplication sentence. And this tells me I have 7 groups of 9. Now, we've all kind of worked with the pattern of 9s, and hopefully you remember how this pattern goes. So you have 9, 18, and remember when you take these 2 digits and add them together, they make a 9. The next one is 27, 2 and 7 makes a 9. 36, 3 and 6 makes a 9. 45, 4 and 5 make a 9. Now, Once I reach this point, now my digits are going to trade place values. So I'm going to take my 5 and put it in the tens place. I'm going to take the 4 and put it into the ones place. So now it goes 54. And then I'm going to switch my ones and tens here, and that's going to be 63. I'm going to switch the ones and tens here, that's going to be 72. Switch my ones and tens here, that's 81. And finally, I don't have a tens place, but I know that there would be 0 here, so this would be 90. Now, I want my 7th group of 9. So this is 1, 2, 3, 4, 5. 9 times 5 is 45. 6, and finally 7. So my 7th group of 9 is going to be 63. All right, let's go ahead and take a look at our other facts here. We have a missing factor here, and since we have a missing factor, I need to know how many groups of blank it takes to make 28. So how many groups of, well, we could count by 7s and see how many groups of 7 it takes to make 28. Or I could take these 28 objects and put them into 7 equal groups. Either way, this should tell me how many objects are in each group. How many objects are in each group. So I'm going to work with counting by 7s since I know this factor. So 7, another group of 7 is, right, 14. Another group of 7 is, you got it, 21. And add 7 more to this 21, and I've reached 28. So now I can count the groups of 7, because remember, these can be switched. So 4 times 7 is the same as 7 times 4, and we know that we can switch the factors and the product will be the same. So my missing quotient here would be 4. Now, again, same thing. Oops. If I know 4 groups of blank equals 12, well, 4 groups of what equals 12? Well, it's not going to be 4 groups of 2 because 4 groups of 2 would be 8. What about 4 groups of 3? Well, let's see. 3 plus 3, that's right, is 6. And another 3 is 9. And another group of 3 is 12. So I have 4 groups of 3 to make 12. So my missing factor here is 3. And finally, 2 groups of what gives me 18. Well, how much could I put in here and here to make this equal? Right, you got it. It's going to be 2 groups of 9. 2 groups of 9, 9 and 9 makes my total of 18. So 2 times 9 is also equal to 18. Now, this last problem is a perimeter problem. And remember, perimeter, and everybody's going to write this, perimeter is the length of all the sides. Length, write this down, of all the sides. Now, since this isn't on grid paper, we don't have a chance to look at what the area or square units would be inside of this particular shape. But we can find the perimeter or the length of all the sides. So what I'm going to do is I'm going to add all the sides, and this is 1 inch here. The length of this line right here is 3 inches. The length of this line right here is 4 inches. And now when I put all the lengths together, I'm going to add them to find the length of all of them as a total sum. So 1 and 3 is 4, and then 4 and 4 more makes 8. So this is going to be a length of 8 inches. Now, you're not going to put square inches because we're not looking for the space inside of this figure. The space that's inside of that figure is called the area. That would be called the area inside. We don't need to know the area right now. We're just wanting to know how long the sides are. So the perimeter is going to be 8 inches. All right, that's it for today. And it just so happens we're going to be starting to work on our perimeter lesson today. So this is a nice start to what we're going to be working on. So see you soon in our math lesson and have a great day, guys. See you soon.